Good morning, everyone. Welcome to the first of hopefully many UQpy training sessions. My name is Professor Michael Shields. I'm a professor at Johns Hopkins University. I'm also joined by several postdocs and graduate students who will be walking you through the various capabilities of UQpy over the course of the next 2 days. I want to give the students and postdocs a special thanks because this is largely due to their hard work. Over the next 2 days, you'll be hearing a lot from them and hopefully learning a lot from them. So in particular, I want to thank Dimitris Giovannis, Akash Bangalore-Satish, Mohit Chauhan, Audrey Olivier, and Lohit Vandanapu, who will be presenting various capabilities over the next 2 days. To give you a quick introduction to what we'll talk about over the next 2 days, I'm gonna start with a brief 10-minute introduction, just getting you sort of a primer for the training and getting set up with UQpy. We will then go to Akash Bangalore-Satish, a PhD student in my group, who's gonna walk you through the Run Model module. The Run Model module is really a core capability of UQpy, and it's really central to everything that UQpy does. And Akash and Lohit Vandanapu are the lead developers for that capability. So Akash will walk you through that. And then we're going to take a short break, probably about 15 minutes after that. And then we'll go into the distributions module, which allows you to define probability distributions in UQpy. And from there, we'll talk about the sampling methods that are available in UQpy. So the first day of the training is really about learning the core capabilities and the core of UQpy, how UQpy is structured, and how it works, how it interfaces with models and the like. Day 2 focuses more on capabilities and what we're doing with UQpy in more advanced UQ applications. So tomorrow we'll start with the inference module, which does essentially inverse problems. And so Audrey Olivier, a postdoc in my group, will be taking the lead on that. That will last about an hour, and we'll take a break after that. Then we will talk about 3 additional modules after the break: the reliability module, which will be led by Dimitris Giovannis, the surrogates module, which will be led by Mohit Chauhan, and the stochastic process module, which will be led by Lohit Vandanapu. So before we get started, I want to walk you through some of the basics that you'll potentially need for this training. So first of all, I want to just take a quick tour through the GitHub site. So I'm going to open up GitHub here, and one moment I will have to make sure that you can see this. Okay, so UQpy is open source developed. We have a GitHub site you can see from the link that I sent in the email. And just a few things to look through the structure of the code. So the source of the code is here. You can see that it's broken down into a set of modules that we are going to talk about over the next 2 days, ranging from how you define distributions to sampling methods and surrogate models and the like. So everything in terms of capabilities is in the source folder. Now, if I take a step back, I look at the example folder. This is where we're going to be running all of the examples that we'll go through through the training session. So we have examples for each of the capabilities in UQpy, and if you're so inclined, you can run these examples locally on your machine if you have it installed. We'll talk quickly about installation in a moment, but each of these examples you can see are defined as Jupyter notebooks. So in order to run the examples, you need to have Jupyter installed on your machine. An alternative to this is if you scroll to the bottom of the GitHub page, you can see that there's a link that says Launch Binder. If I click on that link, what that's going to do is it's going to open up this repository on Binder. And this is going to take a minute or so to load. But what this will do is it will actually link in all of the examples that we have uploaded into the repository. So now you can see I have that same directory structure. You can see I have all the source here. I have the examples, and I can scroll into some of these examples, and I can actually open up the Jupyter scripts here, and I can run those Jupyter scripts remotely. So if you want to follow along without having UQpy directly installed on your machine, you can just click that link on the GitHub page, and that will take you to the binder, which you can use for running the examples. Okay. The other aspect of the training that I want to briefly introduce is that we have set up a forum for our users and for our participants to provide us with feedback. So if you look at the link that I sent in the email last week, there's a link for this forum, and in this forum, you'll see 5 different topics. So the first topic is just general discussion. If you have just general comments or questions about the code, then feel free to post there. The next one is specific to the training session. So if you have questions that are directly related to topics in the training session, if something wasn't clear in the training session, please feel free to post there. The next 2 are related to UQpy's capabilities. So as I'll talk about in just a minute, we have a growing list of capabilities, and if there are particular capabilities that are in high demand, then we'd like to know about that. And so if you have a specific request for a new capability, we encourage you to submit that through there. The other thing is we'd like to sort of survey the existing capabilities and see what people are actually using. So please provide comments in the most used capabilities thread to inform us what you're using most in the software. And lastly, if you find a bug or an issue in the software, please report it. The software is not perfect. It is still under active development. We recognize that there are bugs, that there are issues, and we want to know about them so that we can fix them. Okay. One last note is that we will be recording. These sessions are recorded, and these will be posted online shortly after the completion of the session. So probably within a few days, if not a few days, within a week or so, the sessions will be available online, and I will share an email with all of you pointing you to where you can find those. Okay, so let's get into UQpy a little bit. So UQpy is developed by my group here at Johns Hopkins University. As I mentioned, it's version controlled through GitHub, and you can find the GitHub repository in the link that I've sent out previously. Most of the development has happened in a Mac, although we are working to facilitate use on Windows and Linux machines as well. As you'll see, there are some limitations when we work in Windows, but for the most part, it is fully functional. And lastly, it's distributed through an MIT license, so it is open source, and we encourage people to download the source and to add capabilities that you locally on your machine as you see fit, and take the software and run with it. So we've really provided a framework and a structure that we think is really naturally extensible, and we encourage people to do that. So again, this is just licensing details. It is issued through an MIT license. So UQpy is a collection of modules, and I'll go through the modularized structure of it shortly. But basically, it is set up in such a way that each of the capabilities are modularized so that they can all work together. They can call one another. They can, and they're easily extensible. Obviously, we harness the Python scripting language. And we currently have some of the latest techniques for uncertainty quantification and uncertainty propagation that include things from sampling, inference, reliability, surrogate modeling, and many other capabilities. However, I would mention that we are rapidly growing and rapidly expanding those capabilities. So stay tuned for how this thing grows. A key feature of UQpy is that we have constructed what we call the run model module, which is intended to link to any third-party model. And as you'll see over the next 2 days, we have links to Abacus, MATLAB, and other software that is relatively straightforward once you know the structure of the code. And finally, it's you can download it and develop and use it either as a developer by downloading it directly from the GitHub site, or as just a user installation through the Python package index. It's just a simple pip install UQpy command. You can also install it through Conda. So as I mentioned, UQpy is structured in a modularized architecture. And at the center of that architecture is the run model module. Run model is essentially an API that serves as a link between UQpy and third-party software. Now that third-party models. Now that third-party model may be another Python model, or it may be some third-party software, as I mentioned before, Abacus or LS-DYNA or some other finite element model, or it could be a custom code. It could be something that you have developed to solve your own set of equations. And so run model serves as the interface between UQpy and third-party software. And UQpy is intended to serve as a wrapper around those solvers, which means that it is fully non-intrusive, okay? So our goal is not to perform any form of intrusive uncertainty quantification where we actually have to go in and change the solver for the mathematical system. Instead, we serve as a wrapper around that system to enable various capabilities in UQpy. And those capabilities are set up through the various modules that you see wrapping around the run model in blue. And those capabilities are set up into modules that are basically groups of classes that define capabilities. So those capabilities are what we're going to focus on largely tomorrow. Today we're going to focus on the run model module first, and the sample methods, which is really sort of the introduction to the various capabilities. In addition to these, the primary structure, we have two additional what we call support modules. The support modules are the distributions module, which allows you to define probability distributions in UQpy. And the distributions module largely follows the SciPy stats conventions, but it does so in such a way that it creates objects that are natural to use within the UQpy framework. The second is a utilities support module, which we're not going to talk a great deal about in this training session, but it provides some support functionality, things like diagnostics for Markov chain Monte Carlo and some of the other things that support the main capabilities but do not fall within the realm of being the core capabilities of the software. This is a current list of the existing capabilities in UQpy. As you see on the left, we have it broken down according to the various modules. So starting at the top, we have the run model module, which contains only one class, which is the run model class. The next two are what we're going to be talking about today. So we'll talk about run model today. We'll talk about the distributions class and the sample methods class. And those are really the core of the code. Tomorrow, we will talk about surrogates, reliability, inference, and stochastic process and the various capabilities there. We will not, in this training session, talk about the transformations module. Transformations is just a module for isoprobabilistic transformations, inducing correlations, Nauthoff transformation, that sort of thing, which we will not spend any time discussing here. We also will not discuss in detail the utilities module. Looking forward, we are expanding the capabilities, and we are rapidly growing the code. So sample methods itself will grow to include additional sampling methods, additional random sampling methods, including various stratified sampling techniques that we've developed in our group. We will also expand to include things like sparse grids and quasi-Monte Carlo. And these will be used in support of collocation methods. So we have a number of collocation methods that we are currently developing, from standard sparse grid collocation methods to adaptive methods and simplex stochastic collocation and various other things that we've developed both here in our group and have been previously developed in the field. The surrogate models will also be expanded to include things like polynomial chaos, artificial neural networks, and the like, as well as additional expansions to the reliability and inference packages. We will also be adding 2 additional modules which are not currently functional, the optimization module and a sensitivity module, and have a longer term vision of doing dimension reduction and reduced order modeling in UQpy. A couple things that I want to highlight here. Most of these you see are listed to be released in version 3.0. Many of these will likely be pushed beyond that. However, there are a couple that are nearly complete, which I have indicated as being available soon in version 2.1. That is the AKMCS method, adaptive kriging with Monte Carlo simulation, and the EGO method, the efficient global optimization, both of which are supported by the existing kriging class in our surrogates module. I want to also make a note that none of these future capabilities are guaranteed at this point. This is all subject to change. We're working to implement all of these things at various speeds. Some of them are in progress, some of them are quite a ways off, but this is the vision, and this is where we're hoping to take things over the course of the next several years of UQpy development. And going back to the forum, I would like to encourage you, if you don't see it, if you see something that you would like that is an important development, please add it to our forum and we will take it under consideration. So just a very high level look at how UQpy is set up. So if you go into any one of those individual modules within UQpy, you will see that the basic structure is one of classes. So within each module, you have a number of classes, and each of these classes corresponds to a capability within UQpy. And so everything is structured in this simple hierarchical framework such that adding new capabilities is very, very simple, okay? And it's very simple in the sense that all you have to do is add a new class. And as you saw through the linkages of that sort of web that connected all the modules, these classes are capable of being called by other classes so that everything is fully interconnected. As it is right now, we have the following 8 modules, and you can see that their class structure according to the diagram here. Run model, for example, has 1 class. Distribution has 3 classes: distribution, subdistribution, copula. And you can go through and we will go through each of these modules through the training session and specifically discuss the various classes that exist within each module. So finally, I want to just talk about getting you guys, everyone set up to use UQpy. So UQpy requires Python 3.5 or above. And if you want to run the examples that we have, you also need a Jupyter Notebook install. We have basically three ways that you can install the software. You can do a manual install from GitHub. You can do a user install from either pip or conda, or you could do a developer installation for more advanced users through the GitHub site as well. In order to install UQpy directly from GitHub, you just have to clone the repository and run the setup.py file that exists inside the repository. So you run Python setup.py install, and that will give you a local installation of the software directly from the GitHub site. For more advanced users who actually want to be able to develop new capabilities in UQpy, you can again clone the software from the GitHub site, and then you can run Python setup.py develop. And what setup.py develop does is, rather than directly installing UQpy into your site packages, it creates what's called an egg link. And this egg link is basically a link that lives inside your site packages that points to your current working editable copy of the software. And so it is essentially an installation that sees your local changes, which allows you to run the software with all of the changes that you implement in your version. For basic user installation, without requiring interfacing with GitHub, we support two different ways of installing. The first is you can install through pip, the Python package exchange, with a simple pip install UQpy, or you can install with conda. Conda, if you use the Anaconda distribution of Python, conda is the preferred way of installing. I would, however, caution that this is currently only available on Mac OS. The conda distribution is not currently supported on Windows platform. However, we're working to change this hopefully within the next week or so. Once you have it installed, you can check to make sure that things are installed properly. You can look at the list of packages that are installed through pip by just typing pip list, which you see here at the top. When you type pip list, you should see UQpy should be in that list. If you want a more detailed look at UQpy, you can type pip show UQpy, and it'll tell you what version number. This version number 2.0.2 is the version that we'll be running the training session off of. This is the most up-to-date version of UQpy and was only released last night. So if you want to update your current installation, that may be version 2.0.2 is the latest and is what we'll be using for this training session. Similarly, if you run conda, if you run Anaconda, then you can use conda list and UQpy should show up in that list. So at this time, we are going to transition into the run model module and get into some of the details of the run model module. So now I'm going to turn things over to Akash Bangalore Satish, who is going to walk everyone through the run model capabilities.